Between 1981 to 2010, the mean annual surface air temperature has risen 1.3 Celsius in relative. Starting from the beginning of the 20th century, 2.9 Celsius has risen. Although this increase in the global rate of temperature has slowed down, the Arctic air temperatures have continued to increase. Currently, the Arctic is warming at more than twice the rate, which is called Arctic amplification. One of the effects of the increase in temperature of the Arctic is melting ice. The video shows the ice melting between February 2015 and September 2015. This hinders animals, especially polar bears, to migrate to the North Pole on time, resulting in starvation, disturbance of food chain, and higher extinction rate. The other effect of the increase in temperature of the Arctic is melting tundra. As the temperature rises, more tundras are melting, which is called greening. This causes bacteria to produce carbon dioxide through the atmosphere as they photosynthesize. Therefore, the possibility that future warming could occur rises in a much faster pace, also doubling the amount of heat trapping carbon dioxide in the atmosphere. How is the climate changing in the Arctic? Melting glaciers, sea ice, permafrost, and rising sea levels provide clear evidence of a warming trend for the Arctic as a whole. Observations suggest that precipitation may have increased by roughly 8% across the Arctic over the past 100 years, and that rain now falls mainly in winter rather than in spring or autumn. Other natural factors, such as variations in the solar radiation, major volcanic eruptions, and interactions between the atmosphere and oceans, and factors linked to human activities can influence the climate. Ice cores and the other sources of information about past climate conditions reveal that the current warming trend is unusual and that it reflects the increase of greenhouse gases in the atmosphere induced by human activities. Global temperatures are increasing further during the 21st century. Especially in the Arctic, this warming is expected to be greater than the global average, and the followings are presumed over the current century. The average annual temperatures are projected to rise by 3 to 7 Celsius or 5 to 13 Fahrenheit, with the greatest warming occurring in the winter months. Precipitation is projected to increase by roughly 20%. Sea ice is expected to continue to decline significantly, reflecting less solar radiation and thereby increasing regional and global warming. The area of Arctic land covered by snow is expected to decrease by 10 to 20%. Then, how can Arctic warming affect ocean currents? Through the interconnected movement of ocean waters, that is primarily driven by differences in heat and salt content, the sun's energy is transported from the equator towards the poles. This action is known as a thermohaline circulation. At present, the Gulf Stream current that flows from the Gulf of Mexico to the coast of Europe warms the winds and provides much of the moisture that falls as precipitation over northwestern Europe. As the water moves northward, it becomes cooler, saltier, and denser. As a result, surface water eventually becomes heavier. Therefore, the water sinks deep into the ocean, driving the global seawater thermohaline circulation. Part of this global circulation is known as the Gulf Stream, providing some of the heat that keeps Europe warmer in winter than regions of North America at the same latitude. However, climate change could interfere with the formation of the cold, dense water that drives oceanic circulation. Also, it brings about further changes in climate. Slowing the thermohaline circulation would have several major global effects. For example, decreasing transport of carbon dioxide can contribute to further increases in the level of carbon dioxide in the atmosphere and to further warming due to CO2. Regional cooling is another effect which could result from the slowing of the northward transport of heat by Atlantic Ocean currents. Last, the reduction of sinking of cold, dense water in the Arctic can reduce the amount of nutrients carried back toward the surface elsewhere in the world that sustain marine life living near the surface.
The melting of Arctic sea ice has been increasing due to the climate change, which leads to an increase in endangered species. More importantly is the issue of the base of the food chain because that affects the whole ecosystem. The loss of summer ice is increasing with an extended summertime. More than 2 million square kilometers of ice has melted in the past century, and here are some examples of the endangered animals. Polar bear relies on sea ice surface to hunt, travel, and breed, which means the earlier spring ice melt and a later fall freeze up cause them in danger. The critical timing of sea ice breakup and sea ice freezing is changing in a way that is harmful for the polar bears. Walrus depends on shallow water to hunt. With the shrinking of sea ice surface area, the pack walruses spread infections easier. The beluga whale is a source of food for the polar bears, but with the temperature rising in the Arctic, more predators like the killer whales expand their range into the ice-free waters of the Arctic Ocean. Narwhals, which is among the top of the food chain in the Arctic, depends on sea ice their entire life. Like many other endangered animals, narwhals rely on ice surface as a place to feed and take refuge.
The arrival of newcomers to the Arctic and the introduction of modern hunting technology resulted in some mammals experiencing severe population declines, such as bowhead whales or walrus. Continued human immigration, population growth, advance of technology, and commercial markets for wildlife products resulted in increased harvest pressure on some wildlife populations. Moreover, overfishing or overharvesting for mammals' fur also causes threat to the biodiversity in the Arctic. Even though overharvest was a significant pressure on many Arctic wildlife species before, it was also the most manageable. Nowadays, conservation concern has been raised. Therefore, the historical pressure from overharvest has been largely removed as a major threat for most species. Improved management and conservation actions are based on greater understanding of the potential for harm to species and ecosystems, better regulation and enforcement, and in many cases on greater engagement with Arctic people, which is the living with the wildlife.
In the mid-1980s, scientists began to find elevated levels of toxic chemicals known as POPs, or persistent organic pollutants, in the blood and fat tissues of the Inuit and other people of the Arctic. Scientists say the toxins can cause cancer, damage reproductive and neurological organs, injure immune systems, and cause learning disabilities. These toxins are carried to the Arctic on wind and water currents where they accumulate and magnify in the Arctic food chain. Polar ice can trap contaminants that are slowly released into the environment during melting periods, even years later. The bodies of Arctic people, particularly Greenland's Inuit, contain the highest human concentrations of POPs found anywhere on Earth, levels so extreme that the breast milk and tissues of some Greenlanders could be classified as hazardous waste. Currently, there are little to no invasive species in the Arctic due to the extreme conditions of the area. Species that are brought in accidentally are unable to adapt to the cold. However, recently in an archipelago north of the Norwegian mainland called Svalbard, a team of scientists led by Chris Ware observed 23 non-native species in ballast water brought by commercial ships, the number of which has been increasing steadily as more and more sea ice melts. The scientists honed in on the ability of 8 species to survive in present-day Svalbard, but also predicted whether the species could survive in Svalbard 50 and even 100 years into the future, as the temperature of the ocean increases and becomes a more suitable environment for more and more organisms. Scientists observed that 5 out of 8 of these species could survive by 2100. One of the species predicted to survive is the European green crab, considered to be one of the top 100 worst invasive species in the world due to the amount of destruction they can cause in an ecosystem. Orcas have the second largest brain among ocean mammals. They use their smarts to capture prey in a variety of ways. For example, to catch seals perched on floating ice, one orca will summon others to assist it in catching the meal. The orcas form a tight, linear formation and swim toward the ice, diving at the last second to create a huge wave. The wave then pushes the seal off of the ice and straight into the jaws of an orca waiting on the other side. To catch fish, orcas use air bubbles and their white bellies to herd the fish into a tight ball near the surface. Known as carousel feeding, the orcas then use their tails to whack the ball, stunning the fish for an easy meal. Next, killer whales don't usually hunt narwhals, but melting sea ice has allowed the whales to encroach into narwhal territory. Similar to the wave wash used to capture seals, the orcas will follow the pod of narwhals and charge at them when they are trapped in shallow water. Orcas even manage to prey on weaker whales much larger than them. Very similar to wolves, they take turns attacking the whale until it dies. In some cases, the orcas will jump out of the water and onto the backs of the whales to cover their blowholes and prevent them from breathing. To hunt seals, orcas are the only whales known to purposely beach themselves. They charge the shores to catch seals, then flop awkwardly back into the ocean. Polar bears are known for their incredible patience when it comes to hunting. These amazing animals lurk around holes in the ice made by ring seals and wait for their prey to surface. Polar bears also eat on whales trapped in the ice after making sure the whale is harmless, and scavenge the Arctic for dead carcasses to pick on. In this video, a female polar bear creeps up on a seal basking on the ice. The polar bear is quite thin, so this catch is extremely crucial. However, the seal's blubber alone will be enough to last her 1 week if she is successful. Notice how thin the polar bear looks. That is because only 1 out of every 20 hunts results in an actual catch. Amazingly, this polar bear catches the seal after being extremely patient. Arctic wildlife resources like seals, reindeer, birds, and fish have long been sold on world markets. Arctic seas contain some of the world's oldest and most productive commercial fishing grounds, which provide significant catches for many Arctic countries, as well as for the rest of the world. Also, the Arctic has big oil and gas reserves, and the mineral reserves in parts of Russia and Canada provide large amounts of raw materials to the world economy. Marine access to resources is likely to be enhanced in many places in a warmer Arctic with less sea ice, but access by land is likely to be hampered due to a shortening of the season during which the ground is sufficiently frozen to drive on. Lastly, climate-related changes in Arctic ecosystems will not only have local consequences, but also on a global scale because of the many links between the Arctic and the rest of the planet. Many species from around the world migrate to the Arctic in summer and depend on it for breeding and feeding. Climate change will alter some of their habitats significantly. Expansion of the forest towards the north, for instance, may reduce the size of tundra areas, which are important breeding grounds for hundreds of millions of migratory birds. Indeed, a number of bird species are expected to lose more than 50% of their breeding area during this century, including several globally endangered seabird species. Despite the fact that a relatively small percentage of the world's greenhouse gases originate in the Arctic, human changes in the Arctic climate are among the largest on Earth. As a consequence, the changes already underway in Arctic landscapes, communities, and unique features provide an early indication for the rest of the world of the environmental and societal significance of global climate change. Changes in climate and their impacts in the Arctic are already being widely noticed and felt, and are estimated to become much greater. These changes will also reach far beyond the Arctic, affecting global climate, sea level, biodiversity, and many aspects of human social and economic systems. Because of these reasons, climate change in the Arctic deserves and requires urgent attention by decision makers and the public worldwide.